In this lesson, we'll gain some practical experience in running Microsoft ResNet in a Jupyter notebook hosted on Azure notebooks. We'll use a small pre-trained network to classify various images in this notebook. In this lab, we'll see the ResNet CNN classifier in action. Do you remember what the difference between a classifier and a detector is? We would need some additional functionality to turn our CNN classifier into a detector. We'll construct a ResNet network using the Microsoft Cognitive Toolkit, which was previously known as CNTK. We need version 2.4 of the toolkit, so our lab will use the Python package manager pip to upgrade this if necessary. This needs to be done once per session and will take a few minutes. Its progress messages while it is working are a bit funny in the way that they are displayed, but rest assured it will upgrade successfully. Okay, with the toolkit installed, we'll move through building up the components of our ResNet model. We'll construct some building blocks to allow us to create the residual block, and then stitch some of those together to form the model. Here's a diagram of the layers in our final model. We're using a dataset called CIFAR10 for this lab. We'll need to download it from the University of Toronto where it is hosted into our Azure Notebooks environment. This again needs to be done once per session, and it usually takes about 15 minutes. Python code in our notebook will download and extract the dataset and also prepare it for use with the Cognitive Toolkit. It will divide the set up into training and test portions. Azure Notebooks have two areas of storage. The first is where the notebooks and Python code are kept. This is persistent, but it is slow to access. The second is where we unzip our datasets and where we install any upgraded Python libraries we need. This area is fast, which makes our training run faster, but it is deleted at the end of every Azure Notebooks session. CIFAR10 is a collection of approximately 60,000 32 pixel by 32 pixel color images across 10 different object classes. Optionally with this lab, we can actually do some CNN training. To set some expectations, Azure Notebooks run in small virtual machines with limited RAM, and they do not have GPU acceleration. Therefore, training is likely to be very slow. It can take about 30 to 40 minutes to do just a single epoch. It may be worth running through the notebook once with training disabled and then once with training enabled. As we've deliberately restricted the amount of time we'll spend training, the model we train will be nowhere near as accurate as the pre-canned version that comes with this notebook. You'll see our training is done in mini batches. You can change the size of the mini batch or the number of training examples if you want. Finally, we have some code to make predictions based on the test set and to plot the average results. If you run training, remember that your results will be much worse because of how small an amount of training we do. If you had the processing capability locally, with a powerful GPU, you could always take on the exercise of downloading the notebook and replicating the full accuracy of the pre-trained network that we provided with this model yourself, by training for more epochs. For example, you could try training for 50 epochs or 100 epochs, and use the training curves to figure out when to stop. One quick note on Azure Notebooks. Sometimes the Python processes can get orphaned. They're left behind from a previous execution, consuming resources. As the Azure Notebooks are limited in memory, if you see your Azure Notebook CNN labs failing with Python memory exceptions, it is likely you have one or more of these orphaned processes running. You can select Terminal and type ps space aux followed by return to see what processes are running. Ideally, only one process will be using more than a few % of memory. This should be your running notebook. If you see more processes than this consuming double digits of memory and are getting memory exceptions, especially during training, we suggest you select Shutdown to kill your Azure Notebook session and go again from the top.